Welcome back everyone. Hope you have watched our previous two episodes on mechanics and electromagnetism. If not, link are in the description. Today we are on episode number 3 and our topic is thermodynamics. Now, thermodynamics is a very interesting topic and honestly it is one of those topics where if you concept is clear, you can score very well in the CSCA. So pay attention. Let me first show you what is in the syllabus under thermodynamics and then we go straight to the notes. So here thermodynamics, this is the section number 3, and under the thermodynamics there is kinetic theory of gases. So we will study the important things from the kinetic theory of gases. Then the next subtopic is it ideal gas equation of states. Okay, first lab thermodynamics. So there is the three subtopic which we will cover in this lecture. Okay, so let's begin. This is the section number 3, thermodynamics, and in thermodynamics the first subtopic is the kinetic theory of gases. So what is so in this we will study the basic assumption. So the basic assumption number first is that gas consists of large number of molecule and random motion. The basic assumption number first is say that gases consist of large number of molecule and random motion. Then the second assumption is that volume of molecule is negligible compared to gas molecule. Here they say that the volume of individual molecule is negligible as compared to the whole gas volume. Okay, now the third assumption is that they say that no intermolecular forces except during collision. There will be no intermolecular forces except when there is a collision. Then there may have intermolecular forces, but in the normal condition there is no intermolecular forces. And the fourth basic assumption is that collision are perfectly elastic. Perfectly elastic mean that the total amount of energy must be conserved. Okay, and the fifth assumption said that gas pressure is due to a molecular collision with container wall. Here said that gas pressure is due to molecular collision with container wall. Here mean that there will be the gas pressure only when when the gas molecule collide with the container wall. So the basically the pressure that is built inside the container, it will be from the molecular collision with the container wall. Okay, now we will study important formulas from this. Here the formula number first is that pressure of gas. So the pressure of gas, the formula is that 1 over 3 density c square. Here this sign represent density and c represent the speed sphere. Sorry, you have see it is here written that this sign represent density of gas and c represent root mean square, which is speed. Okay, so root mean square speed, what is that? But this the formula is that we will use c is equal to 3 under the root 3, and p is the pressure, and this sign is for density of gases, and it is also is equal to 3 RT and 2 m. Okay, now the average kinetic energy per molecule, what is this formula? This formula is equal to 3 over 2 kT. K is the constant and T is the temperature. Average kinetic energy per mole, this is the next formula which you must memorize, as that is equal to 3 over 2 RT. And the next next point, important point that you must memorize is that kinetic energy depend only on temperature, not on pressure or volume. Okay, so it depend only on you must see that kinetic energy depend only on temperature, not on pressure or volume. Okay, Now the next subtopic is ideal gas equation of state. Okay, so what is this? This is first of all gas laws. We will study gas laws, and gas law, first one is Boyle's law. Boyle's law said that pressure is inversely proportional to volume at constant temperature. Now the second law is Charles' law, which said that volume is directly proportional to temperature at constant pressure. Next is pressure law, which say that pressure is directly proportional to temperature at constant volume. Ideal gas equation is equal to phi V is equal to nRT. Here R is 3.8.314 joule per mole per Kelvin, and T is the absolute temperature, which is in the Kelvin. Okay, here. Now go to the next subtopic, which is the last subtopic, and this is the first law of thermodynamics. First law of thermodynamics statement is that heat supplied to a system is used to increase internal energy and do work. Okay, so the statement of first law of thermodynamics, they say that heat supplied to a system is used to increase internal energy and do work. Okay, so from this statement we derive the mathematical form, which is that heat supplied to a system is used to increase the internal energy and do work. Here Q is the heat supplied, and delta U is the internal energy, and delta is representing change in internal energy, and plus is the work done. W represent work done. What is internal energy of ideal gas? So internal, to calculate internal energy of ideal gas, this is equal to delta U is equal to NCV delta T, and it's only depend on temperature. Okay, so NCV delta T is the formula for the calculating internal energy of ideal gas. And that is for episode number 3. That is enough for the episode number 3. Thermodynamics is also done. We are making a very good progress in our CSCA Physics Series, mechanics, electromagnetics, and now thermodynamics all covered. Episode number 4 is coming soon, so subscribe if you haven't already and turn on the bell notification. Any question, write them in the comments below. I will answer. Okay, and the last, thank you for watching. See you in the episode number 4.